Good afternoon, everyone, and welcome to a brand new week. It's not a brand new week. Monday was a brand new week, a brand new topic, and that is motion in one dimension. In the last class, we had dealt with units and dimension, and I have sent the sheet again, both for units and dimension and for this entire chapter. Did you get it? The sheets?
No, sir.
I think you will get it by the end of the day today. So what you got to do is, remember, you always have to remain in pace with the classroom lectures. So I have sent you the sheets on units and dimension as well as 1D. What you do is, first you will try questions from 1D, cover up till what we have done, and then get some spare time and then try the questions from the previous part. Okay. So what I'll do is, before the beginning of any new topic, I'll be 1 day or 2 day before, I'll be sending the sheets, the DPPs of that part, so that you can remain in pace with the course flow. And remember, don't have to do anything extra. If you can just solve the sheet that I sent you, that is much more than enough that you will require to clear your exams. Okay. So even if you don't do any extra question, if you just concentrate on the question that we do in the class and you solve the sheets that I have sent you, that is much more than enough that you will ever require. We understand this?
Yes, sir.
Okay. Having said that, let us now move on to the topic for today, motion in one dimension. And quickly, I guess you know what do you mean by motion in one dimension. Tell me fast, what do you mean by motion in one dimension? What do you mean by motion in one dimension? Tell me fast. You know this, right?
Object moving in a straight line
Yes.
in one dimension.
Can you speak a bit louder, beta? It's very hard for me to understand what you are saying.
Sir, is it audible, sir?
You are audible, but your voice is very low. I mean, can you just increase the mic volume from the setting? I think either you are speaking too slow or your mic is too low. Do you know how to do this from the settings, or you can speak a bit louder?
Object moving in a straight line, sir.
Object moving in a straight line. Okay. Fataksi, we will go. When I talk about motion, this motion can be subdivided into, let us say, 3 categories, and we'll fatafat. You don't have to note it down, you just have to see it. The first is your translational motion. Do you understand the meaning of translational motion?
Yes.
One is translational, the other one is rotational. What is the third one then? It's a combination of translational plus rotational. Do we know this? This type of motion, rotational motion and translational plus rotational, the combination will come in a chapter known as rigid body or rotation. We don't have to be concerned about right now. What we need to be concerned about right now is this translational motion. Now this translational motion can again be further subdivided into 2 categories. What are those 2 categories? The first one is known as rectilinear. Rectilinear motion. This rectilinear motion is nothing but motion in 1D. Do we understand this? The body is going to travel in one dimension or a straight line only. That type of motion is known as rectilinear. Then the other type of motion is known as curvilinear, in which you will have 2 types of categories. It would be either motion in a plane, which we call motion in 2 dimension, or the general motion in space, which we call it as 3D. We all understand this small thing?
Yes.
So this is how we begin our discussion, and the easiest of them all, I mean, all of them are easy, but the easiest of them all will be this one, which is a straightforward study of motion in a straight line. Bodies are going to move in a straight line. They are not going to move zigzag to start with, or let us see. So this is how we have to start our series on this particular topic. We understand this?
Yes, sir.
Now, once we understand what do you mean by motion and the different types of motion, then we must also understand what we will need to understand or to study this motion. So what are the tools required to understand this motion? If I have to study the motion, what are the tools we require? The first tool that we require, the first thing that we require is we require an observer. Do we understand the meaning of an observer? We need someone to observe the motion. If there is no observer, the motion cannot be understood. Yes or no?
Yes, sir.
Then what else we require? We require something known as reference frame. Do you know what do you mean by reference frame?
Yes, sir. Yes.
Reference frame is the place from where this observer is going to observe that motion.
Observe.
This
Yes.
reference frame, to start with, to begin with, would be your earth, your ground frame or laboratory frame or whatever you call it. That is your ground frame. But as we will see that sometimes to study the motion from ground frame may not be so simple. The motion may look very complicated. So we may have to switch on to different reference frame, moving bus, moving train, moving plane, and so on. Reference frame is the most important thing because depending on the reference frame, your motion can change. In one reference frame, your motion can be look like the body is not moving at all, but in the other reference frame, the body may look like it is moving. Do we understand this? Yes or no?
Yes, sir.
So the most important factor to understand motion is this factor. And what is this factor? This factor is the reference frame, because if you change the reference frame, things may start to look different. I hope you know this. So let me move ahead with the third point. And the third point to understand motion is that we need something that can tell us the time. So we need a timing device. Do we understand this? So we'll need a timing device. Whenever we talk about reference frame, we must have a X, Y, and Z axis, and we must have an origin for a reference frame. And depending on your reference frame, your origin, your X and Y axis, you can understand where the particle is. Yes or no?
Yes, sir.
Okay. So these are the tools we require. We know about this. Yes or no?
Yes, sir.
Now the next thing that we may require, and we must know what is this, is something known as position vector. Do you know what is position vector? Do we know what is position vector?
Yes, sir.
What is position vector? Tell me fast, so I can move pretty fast. Yes, bacha. Tell me what is reference frame. Tell me what is a position vector. Tell me.
Position with respect to object from origin.
Yes.
Position with respect to object from origin.
It tells me the. Yes, yes. It tells us the.
Sir, is it audible, sir?
Yes, yes, you're audible, bacha. Tell me. What is the position vector? We understand this x axis, y axis, yes or no?
Yes, sir.
Now, with this axis, can you tell me what is a position vector? Now, we have this axis, so we will have an origin and we have some point, let us say A. Now, can you tell me what do you mean by position vector? Tell me fast. Position vector, the meaning of the term is hidden in the term itself. Position vector of a point or an object is nothing but a vector which tells us the position of this particle with respect to the origin. So this OA vector This OA vector, if I call this OA vector is the position vector of point A with respect to O. Do we understand this?
Yes, sir.
So if you know where is O, you can find out the position of this point A with drawing a vector. The vector which tells us the position of point A with respect to the point O is known as the position vector. Do you understand this?
Yes.
Okay, position vector. That is the position vector. It tells us the position of a particle. Have you noted this down?
Yes.
What is the next thing that will come to our mind when we talk about motion in 1D? I hope we all know this, right? Right. What is the next thing? Remember, the first class is all about definition, understanding those definitions, and then we will try to use them in the coming classes. What is the next thing that is going to come? The next thing that is going to come is the definition, the first definition. What would be the first definition that is going to come? The first definition that is going to come is definitely for distance traveled of by a particle. Now I ask you again, what do you mean by distance traveled by a particle? Right. What do you mean by distance traveled by a particle?
Speed per unit time.
What do you mean by distance traveled by a particle?
Speed
Just say
into times.
yes.
Speed into times.
Speed into time. That is the distance traveled by a particle. No, that is not there. Remember, you cannot define something with something that we have not defined still. Have I defined speed? So you can tell me distance is speed multiplied by time. I have not defined speed, my dear friends. How can you define speed? How can you define distance by speed? Can't define distance by speed. No idea. What is distance? So this is my origin. This is my reference axis, x-axis and y-axis. The particle is here at point A. It might go to this point B. And as you can see, it might follow any path. Now tell me, what is the distance traveled by the particle? Speed into time? No, that is an absolutely not correct answer. How do you define the distance traveled by a particle? First, this is the most basic definition. No idea? Sir, no idea? Yes, sir, idea. No or yes? I did tell me there is no harm. I don't know quantum physics. Of first class, I said for quantum physics, I'll always say this, sir. I know, and I have no idea. That's why I'm here. No idea? Okay. Now, whenever we talk about distance, I move from, or a particle moves from point A to point B. It travels a path. This is the path that the body has traveled. It travels a path. Yes or no?
Yes.
Now, can you tell me what is the distance traveled? What do you mean by distance? It travels a path. This path has a length. This path has a length. Yes or no?
Yes.
The length of this path is known as the length of this path is known as Distance traveled. So the distance traveled by a particle, the first point you must always remember, it is the path length. Path length, and therefore I always represent distance traveled by this letter L, so that whenever this letter L comes in my mind, the first thing that comes in my mind is the length. It is path length or length of the actual path. It is the length of the actual path followed by the body. Since it is length, we must always know which path it has followed to find out the distance of the particle. Distance traveled by the particle is the length of the actual path followed by the particle. Yes or no?
Yes, sir.
Do we remember this? Something, have you heard like this something before? Okay. Now, what type of quantity is distance? Remember, it is length of the path. And what type of quantity is length? Scalar or vector? Huh? There is a confusion here also.
Vector, sir.
Distance is a vector quantity.
Scalar, sir.
Distance is a scalar quantity, beta. How it can be a vector? The length of this pen, it cannot be having any direction. It is a scalar quantity. Okay, not a problem. What is the SI unit?
Meter.
SI unit is meter. Dimension is capital L. Yes or no?
Yes, sir.
It is a scalar. Remember, it's the length of a path. Now, you take this pen, and if I talk about the length of this pen, and I say it is 10 centimeters, whether I measure it like this or I measure it like this, it is always positive. Yes or no?
Yes, sir.
It cannot be negative, and therefore distance is always positive. Do we understand this? Yes or no? No or yes?
Yes, sir.
Why it is always positive? Why is it always positive? I just told you. Yes. Why is it always positive? Don't move your hand. Say something. Why is it always positive? Because it is. Why is it positive? Because it is. Did you hear when I told you why is it always positive? Because it is length of the path. Length cannot be negative. Therefore, it is always going to be positive. We understand this now?
Yes, sir.
Okay. Now since it is a scalar and scalar are just numbers, distance can be added just like numbers. We don't need any additional law. It is added like numbers. Why it is added like numbers? Because it is a
Scalar.
scalar quantity. So if I ask you this simple question, I go from A to B and I can follow this green path and I've traveled a distance of 5 meters. Then I come back from B to A in this blue path and I traveled a distance of 2 meters. What is the total distance traveled by this man? It's going from A to B and B to A.
7.
And the answer is
7.
7. So it can be just added like numbers. Do we understand this? Yes or no?
Yes, sir.
Since it is the length of the path, therefore it is always positive. Since it is the length of the path, it depends on the path. On different paths, it can be different. Do we understand this?
Yes, sir.
It depends on the path for the simple reason because it is path length and therefore it has to depend on path. If I go in one path, the distance would be different. It can be different. If I go in another path, the distance could be different. Do we understand this?
Yes, sir.
Yes or no?
Yes, sir.
Can I have raised hands from everyone that we understand this? Okay. That's all. That's everything that you need to know about distance. Go through this, note it down. I'll give you 1 minute. I hope you have understood this, right?
Yes,
See, there is no shame in saying no. If someone asks me something and I don't know, I'll just say no. I don't know it. That's it. You should not be conscious of the fact that you don't know something. I don't know everything in this universe. I only know a very small bit of it. No one knows anything about the universe, right? We all know something that the other person does not know, and we also not know something that the other person knows. That makes us human. So please, if you don't know anything, if you don't understand anything, please ask and don't feel shy about it. Okay? Have you understood the meaning of the term distance? Yes or no?
Yes, sir.
That will take us to the next term. And what is the next term?
Displacement.
And the next term is?
Displacement.
And when I ask you what do you mean by displacement, what is the first thing that comes to your mind?
Shortest distance.
The first thing that comes to your mind is shortest distance. That may not be the first thing that should have come to your mind. Think again. Think again. If I ask you what do you mean by distance, think again. What is the first thing that comes to your mind? When I talk about displacement, what is the first thing that should come to your mind? The first thing that should come to your mind is displacement is a vector quantity.
Vector quantity.
Well done. See, we are talking. Displacement is a vector quantity. That is the first thing that should come to your mind. What is the SI unit? Let us say the SI unit is same as meter. Yes or no?
Yes, sir.
Now, since we understand that this is a vector quantity, now let us think about what actually is your displacement. When I talked about displacement, the first thing that you told me was shortest distance. Okay, it's a vector quantity. Distance is a scalar quantity. Let's keep them apart. Let me just take you back to the previous diagram which I had drawn. A particle had moved from point A to B in this path, right? The length of this path is known as what? The length of this path is known as what? Body has moved from A to B following a certain path. The length of this path is known as? What is the length of the path known as, bacha? You don't know? If I move from A to B, what is the length of the path known as?
Distance.
The length of the path is known as distance. Clear, na? Sure, na? Length of the path is known as distance? Sure? Sure or not?
Sure, sir.
Okay. What about displacement? Remember, displacement is a vector quantity. So if a particle goes from point A to point B, if I talk about displacement, you have to tell me something about the vector. So now think again. I'll give you 1 minute to think. Displacement is a vector quantity. Particle has moved from point A to point B. This point A is sometimes known as the initial position. Do we understand this initial position? This is known as initial position, and this is known as
Final position.
final position. Right. Now, can you tell me what do you mean by displacement? What is the displacement of the particle? The particle has moved from point A to point B. What is the displacement? And the answer is displacement is the vector AB. When it moves from A to B, the displacement is the vector AB. That specifies everything that we need to know. Displacement is a vector quantity. So I have told you that the displacement is AB. So now I can write what is the displacement of the particle. It's a vector joining. Vector joining what? Vector joining what? Initial position to final position. And that is the best possible definition that you can give for displacement of a particle. It is a vector joining initial position to final position. In this case, this vector is given by the vector AB. AB vector is your displacement vector. A is the initial position and B is the final position. There is another way of writing the same thing, and you can call it as change. Displacement is the change in PV. What do you mean by PV?
Position vector.
Yes, now things are taking shape. It's the change in PV. When the particle moves from point A to point B, the position changes. And therefore, the position vector also changes. Look here, my dear friends. Initial position. The vector was OA vector. That was the position vector. Yes or no? No, yes.
Yes, sir. Yes, sir. And here
That was the position vector. OA vector was the position vector. Now, when it comes to point B, the vector has become OB vector. So basically, the position has changed. The position vector has changed. That change in position vector is known as my displacement. Yes or no?
Yes, sir.
So if it is change in position vector, I write it like this: delta R vector. Delta meaning delta stands for change. Yes or no?
Yes, sir. Change.
And this R vector stands for position vector. Do we understand this?
Yes.
So whenever I am going to write about displacement, I am going to write it as delta R vector, so that I remember that it is change in position vector. Do we understand this?
Yes, sir.
So far so good. So this will be FPV minus IPV. What do you mean by FPV and IPV?
Final position vector minus initial.
Final position vector, which is OB vector, minus
OA
initial
vector.
position vector, which is OA vector, and this is but nothing but your AB vector. That is the very nice, precise definition of your displacement vector. And please understand that this displacement vector has got nothing to do with distance. So if you have ever called this as shortest distance, well, you have not understood the word properly. Do we understand it now?
Yes, sir.
Pakka? Now, since you have always thought about displacement vector somehow related to shortest distance, now let me clarify why you call it the shortest distance. Let me now go back to the term that this is a vector quantity. Now, first of all, I have defined it in the correct way. Whether you call it by this equation, or you call it by this equation, or you call it by this equation, or you call it by this equation, these four are the actual equations of displacement or the actual definition of displacement. But if you want to understand it in a different way, you can also try this way to understand this, and I am going just to tell you how you can understand this in a different way. Since it is a vector quantity, this vector should have two things coming into it. What are the two things that this vector should have?
Magnitude and direction.
One is the magnitude, and the other one is the direction. It should have these two things. If it is a vector quantity, it should have these two things. It should have magnitude and it should have direction. Now, as soon as the magnitude of displacement comes, we will always call it magnitude of displacement vector. Now, when you're talking about the magnitude of displacement vector, now you can call this magnitude of displacement vector as the shortest distance. So whenever you have used the word shortest distance, my dear friends, you have always meant it for one thing and one thing only, and that one thing was the magnitude of displacement. But if you only talk about the magnitude of displacement, my dear friends, you will not do a good job, because displacement is a vector quantity. You have only told one half of displacement, the other half goes missing. Never forget to remember the other half, or never forget the other half, which is direction. And what is the direction of displacement? The direction of displacement is from IP to FP. What do you mean by IP and what do you mean by FP?
Initial position and final position.
Initial position to final position. Do we understand this?
Yes, sir.
I hope this displacement thing is getting clearer in our head. Yes or no?
Yes, sir.
Okay, it's a vector quantity. Okay, now tell me. Now tell me. We had seen distance. It is a vector quantity. Can it be added or subtracted like numbers? Can displacement be added or subtracted like numbers? Can I treat it like a number? Since it is a
Yes,
vector
sir.
quantity, it cannot be added. It can't be added like numbers. I cannot treat it like numbers. So how can I add it or subtract it? We have to use vector laws. Do you understand vector laws?
Yes, sir.
Vector laws are used to add and subtract. Do we understand this?
Yes, sir.
So remember, it's a vector quantity. It cannot be added or subtracted using simple numbers. It is added or subtracted. It is added or subtracted by vector laws. Yes or no? We understand
Yes,
this?
sir. We understand.
Okay. Now, tell me, if I go from A to B, if I go from A to B in the blue path, if I go from A to B in the blue path, there would be some distance traveled. The displacement would be AB vector. If I go from A to B in this green path, will the distance be same or will the distance change?
Change.
Will the distance remain same or will the distance change?
It may change, sir.
It will change. What about displacement? Does it remain same or
Displacement will not.
yes? Say. What about displacement? Does it change or does it remain same?
Displacement will not change, sir. Distance change.
That means displacement does not depend on,
On the path.
it does not depend on path. So no matter how you go, it's very easy to find out displacement because you don't have to worry about the path. You just draw a straight line joining the initial and the final position, and that is your displacement vector. Yes or no? No, yes.
Yes, sir. Yes.
It only depends on what?
Initial and final point.
Very good. IP and FP. If your IP and FP remains same, your displacement remains same. So far, so good. Anyone having any doubt on this? Please
No,
raise.
sir.
Have you noted it down, bacha?
Yes, sir. Yes.
I hope everyone is noting it down and we'll just go through a quick comparison of distance and displacement. A quick comparison. I hope you are noting everything down. Yes or no?
Done, sir. No.
When you move on to a quick comparison, so that we can just compare it. The first comparison is like this. The magnitude of displacement. Understand the meaning of the term magnitude of displacement. Do we understand this?
Yes, sir.
It is equal to the minimum or the shortest distance. Yes or no?
Yes, sir.
Therefore, your distance travel will always be greater than or equal to the magnitude of displacement. We understand this?
Yes, sir.
Because distance depends on path. The shortest path is the straight line path. That is your displacement ka magnitude. So displacement ka magnitude will always be less than or equal to distance traveled. Yes or no?
Yes, sir.
In which case is distance and magnitude of displacement same? When can we say that distance traveled by the body and the magnitude of displacement are same? In what case?
When the path is a straight line.
When the path is straight. Okay, let me give you an example. The particle goes from A to B in a straight line path like this. The distance traveled is 5 meters. Then it comes from B to A in the green path and it travels 3 meters. It is always moving in a straight line. Now, when I say from A to C, what is the distance traveled by the body? A to C.
2. A to C is 2.
It has gone from A to B and then it has gone from B to C. What is the distance traveled by the body?
8 meters.
8 meters. Remember, it is still moving in a straight line. What is the displacement of the body? Magnitude of displacement. Is it 8 meters, the magnitude of displacement? No, it is not 8 meters. It is now 2 meters. The particle has still moved in the same straight line. So whenever we talk about magnitude of displacement and distance are same, it has to keep moving in the same straight line and never turn back. Do we understand this? If it
Yes,
turns back, even then distance and magnitude of displacement will be different. We understand this?
Yes, sir.
And if it goes in any other direction, then they are definitely different. Yes or no?
Yes, sir.
So distance and magnitude of displacement are only same in one case and one case only when the particle keeps on moving in the same straight line, never turning back. Do we understand this?
Yes, sir.
That is the first thing that you must remember about distance and displacement ka comparison. Do not get confused. Remember, whenever in a question you are asked displacement, you are very lucky because it is very easy to find displacement because it is straight line. But whenever they ask you what? Distance travel, then be careful because it may happen that the particle has turned somewhere and then you will have to understand the entire motion to find out the distance travel because you have to look at the path. Do we understand this?
Yes, sir.
Then we move on to the next point, and the next point is very simple. For a moving particle, a particle which is moving, distance can never be 0 or negative. Yes or no? Because it is the length of the path. Length of the path cannot be negative. We understand this?
Yes, sir.
But we can have 0 displacement. When can we have 0 displacement? The particle is moving, but it can have 0 displacement. In what case it will have 0 displacement?
When it reaches to the initial position.
When it comes back to the initial position. Yes or no? We understand this?
Yes, sir.
So, if the particle is moving in such a way that it comes back to its initial position, displacement can be 0, but displacement can be 0, but distance traveled by that body will never be 0 if it is moving. Do we understand this?
Yes, sir.
Then there is one more term that comes to us, which is positive and negative displacement. What do you understand by positive and negative displacement? Remember, whenever someone...
Direction.
Well done. The positive and negative only stands for its direction. What do I mean by this? If I call something moving along positive x as positive, then something moving along negative x will become negative. So positive and negative displacement or positive and negative velocity or positive and negative acceleration only refers to its direction. Do we understand this?
Yes.
Similarly, if something moving along positive y-axis, we call that vector as positive, then something moving along negative y-axis will automatically become negative. Positive and negative only refers to its direction. Do we understand this?
Yes.
And this thing that we have done, we are going to use it in motion in one dimension. We are going to use it in motion in one dimension, and we call it sign convention. Do we remember this? Sign convention in motion in one dimension.
Yes.
And we will always keep the same sign convention because I don't want to change the sign convention depending on whether the particle is going up or the particle is going down. For me, anything moving, any vector along positive x, I will treat it as positive. Any vector along negative x, I will treat it as negative. Any vector which is directed upwards is positive. Any vector which is directed downwards will be negative. For example, acceleration due to gravity is going to come. Motion in gravity, it is always vertically downwards. Yes or no?
Yes, sir.
So for me and for you, that will always remain negative. We understand this? Yes or no? No, yes.
Yes, sir.
So this is what we understand or we mean by what? Positive and negative displacement. So far, so good?
Yes, sir.
Pakka?
Akka, sir.
If anyone has any doubt, please
No,
raise.
sir.
And I hope you are noting it down and not just chit-chatting.
Done, sir.
Done, sir?
Yes, sir.
Okay. Then comes the next point, sir, and it is, we have already discussed, for motion between 2 points, displacement is always single, does not depend on the path, but distance depends on actual path. So if you go in different paths, distance would be different. Yes or no? No, yes.
Yes, sir.
We have written it many times. Yes or no?
Yes, sir.
Okay, well done. I hope we are moving at a good pace and we should be able to complete this. Then comes the last 2 points. We have already discussed them. I'll just show them to you so that there is no doubt.
No, sir.
And it is this. For a moving particle, distance never decreases. Distance is always positive. You're always traveling positive distance. Yes or no? You understand this?
Yes, sir.
Whenever you are traveling, distance can never be negative. So distance is always increasing or distance is always positive.
Yes,
In
sir.
general, the magnitude of displacement is not equal to the distance traveled. Yes or no? We understand
Yes,
this.
sir.
In
Yes,
only
sir.
one case, it is equal when it is always moving in a straight line
Moving in a
without
straight
turning back.
line.
Now, this is the same case. The particle goes from A to B. The length of the path is the distance traveled. They have written it as S. I will
S.
write it as L. L stands for length. That is why I use it as L. Then the displacement is final position vector minus initial position vector. Do we all understand this? Yes or no? No, yes.
Yes, sir. Yes.
This is all about distance and displacement that you must understand. Do we understand this?
Yes, sir.
Can I now put a question
Okay, sir.
for you to solve? Yes or no?
Yes, sir.
And here is the simplest possible question in this entire universe. And it comes to you. I'll give you 2 minutes. Think about it and solve it. Do we have the answer here, bacha? Yes or no? No, yes. Say. Either we have an answer or we don't have. No?
We don't know, sir.
Yes, bacha? Okay. So how are we supposed to do this? We can take this as our coordinate system. This is north, this is south, this is, I think, west, and this is east. Do we understand this? Yes or no? We understand this? I can't hear you, beta. Do you understand this?
Yes, sir.
Okay. So the first case, what happens is it moves 10 meter north. So let me take it like this. From O to A, it has moved 10 meters. We understand this?
Yes, sir.
Then what it does, it moves 20 meters towards east. So let us say this, it moves to point B, 20 meters. The first question I'm going to ask you, what is the distance traveled by this body?
$30.
The distance traveled is 30 meters. You just got to add 10 meters with 20 meters length of the path, and the distance traveled is 30 meters. What about displacement here? To find out the displacement, you just have to join the initial position with the final position. Yes or no?
Yes, sir.
So this OB vector is your displacement vector. Yes or no? Yes or no?
Yes, sir.
You just have to find out the length of this line OB. That will be your magnitude of displacement. You can find it, yes or no?
Yes.
The length of the line OB. You can find it out from the Pythagoras theorem, yes or no?
Yes, sir.
So length of the line OB will be equal to under root of 10 square plus 20 square.
500, sir.
Yes or no?
Yes, sir. It's root 5.
So it will be 10 root 5. Yes or no?
Yes, sir. 10 root
10 root 5. Now when someone says 10 root 5, what is he referring to? He is referring to the what does this 10 root 5 signify? It signifies the magnitude of displacement. Do we understand this?
Yes, sir.
It is the magnitude of displacement, but that is only one part. You have to also tell me the direction. How do you tell the direction of displacement? You tell me the value of this angle theta. This is the angle that it makes with the north direction. You can find out the value of this theta, yes or no? You can find out the value of tan theta with the north axis, with the north direction. Tan theta will be equal to perpendicular divided by base, yes or no?
Yes, sir.
So 20 divided by 10, that will be 2. So I can say theta will be tan inverse of 2 with the north direction towards east, not towards west. So that would give me the direction of displacement vector. The first thing gives me the magnitude. The second thing gives me the direction. If I put both of them together, I get the displacement vector. Do we understand this? Yes or no?
Yes, sir.
Whatever I have done here, my dear friends, it is one way of telling you the answer. This is the way where I have told you by magnitude and displacement, magnitude and direction. Do we understand this?
Yes, sir.
This is way number 1. This is way number 1. Now I can do the same thing in a different way. How I'm going to do this in a different way? Way number 2. Now OB is a vector. OB is a vector, yes or no?
Yes, sir.
I can write this OB vector in terms of I, J and K. Now, if you look closely, if I take this as my origin, this would be my plus X axis, yes or no? And this would be my plus Y axis, yes or no?
Yes, sir.
I have a unit vector I along X axis and I have a unit vector J along J axis. J along Y axis, yes or no?
Yes, sir.
I can write this OB vector in terms of I and J. I can write it like this. It is 20I plus
NJ.
10K. This is another way of writing the same thing. Here I've written it more beautifully because I've just told you the vector. I don't have to tell you anything else. If you want from here, you can find out the magnitude of this OB vector, which will be simply equal to 20 square plus 10 square, which is same as what we did in the previous example. You can also find the angle from the north axis or the y axis. To find the angle from the north axis, to divide the x component by the y component and you get your previous answers. Do we understand this? What's happening here? Why everyone has to call up during this time only when we are doing the class? Who calls up during this time? Okay. So as you can see, this is your way number 2. We understand this?
Yes.
So either you can use way number 1, magnitude and direction, or you can use way number 2, where you write it as a vector. In both the cases, the answer remains the same. Do we understand this?
Yes, sir.
Pakka?
Yes, sir.
Can I give you one more last question?
Yes, sir.
Okay, and then I have already sent the sheet. There are questions marked in that sheet, and you can do those questions which have distance and displacement only. Those are the questions that you have to do. This is a question coming up for you. Ram takes path 1, straight line to go from P to Q, and Sham takes path 2, semicircle. Find the distance traveled by Ram and Sham. Find the displacement of Ram and Sham. You can do this, yes or no? Okay. Can you do it? Or shall I give you this as homework?
We will do now, sir.
Okay. Distance traveled by Ram. First case. What is the distance traveled by Ram?
100 meters.
100 meters. Well done. What is the distance traveled by Sham?
100 meters.
It is the length of the path. This path is a semicircle. The radius of this semicircle is 50 meters. Yes or no?
Yes.
So it will be equal to pi multiplied by r. Yes or no?
Yes, sir.
Pi multiplied by
multiplied by
50. So the
50.
answer will be 50 pi.
50
Do we
pi.
understand this?
Yes, sir.
Displacement of Ram. So it will be 100 meters.
Yes, sir.
That is the magnitude. Direction is from P to Q. Do we understand this?
P2. Yes, sir.
What is the displacement of Sham? The displacement of Sham is same because the initial and the final positions
Final
are same.
positions
Do we
are
understand this?
Yes.
They have traveled different distances, but they have the same displacement. For Ram, the distance and magnitude of displacement are same because he travels in a straight line. We understand the entire concept?
Yes, sir.
Well done, sir. So that brings us to an end of this class. I've already sent you the sheet. There will be 6 or 7 questions in that sheet based on distance and displacement. If you can do those questions, you are good enough for clearing distance and displacement. You would have also your sheet as well, your booklet. You have got that notes.
We
Module.
actually got the we actually
Yeah, so
got
you can
the
try questions on the module as you got the module, no?
Yes, sir. But we
Uh,
got the basic mathematics module.
I'll ask them to give you this module as well, so you can try questions from this module as well. Okay.
Okay, sir.
If you have any doubts, please tell me else.
And sir, in units and dimensions, there will be also problems on screw gauge vernier calipers and significant figures.
Sorry. Tell
Sir,
me again.
in units and dimensions, we also have the problems on screw gauge vernier calipers and.
We'll do that. We'll do that. That error part and screw gauge part we'll do it at the last.
Okay, sir.
Right now, just units and dimensions because that is required to carry on our thing. And we'll do screw gauge and vernier caliper and errors in a different
Yes,
class.
sir.
Okay. Chalo then. I'll see you in the next class. Take care, and before coming to the next class, please go through this. Okay.
Okay, sir. Thank you, sir.
Bye, bacha. Take care.
Bye, sir.